Handling wet gas. For gas reservoirs, we often observe associated liquid production at surface, yet the fluid is single phase in the gas reservoir. Such systems are referred to as wet gas. Therefore, the downhole model response of a wet gas system should be the same as dry gas, with equivalent gravity. This example illustrates these observations. Click on PVT and diffusion in the ribbon at the top and access the PVT definition for the analysis. The fluid type is set to wet gas with an equivalent gravity. This gravity is calculated based on the surface gas gravity, liquid gravity, and total GOR. Validate the PVT setup. Click on New in the ribbon at the top. Call the new analysis Dry Gas Linear and accept all the default selections to create a duplicate of the current analysis. Access the PVT definition for this analysis and set the fluid type to dry gas. Set the dry gas gravity equal to the equivalent wet gas gravity in the previous analysis. Validate the PVT setup and regenerate the analytical model when prompted. Compare the two model responses. The two model responses are identical as expected. Create another duplicate of the first analysis and call it wet gas num linear. Click on Numerical in the control panel. In the Model dialog, click on Reset from Analytical and generate the model. Duplicate the current analysis and name it wet gas num NL. Click on PVT and diffusion in the ribbon at the top. Toggle to the numerical modeling page and enable the Use Real PVT flag. Click on Numerical in the control panel and generate the model. A nonlinear model is now generated. For single-phase gas cases, a linear numerical model with material balance should give the same response as a nonlinear model. Compare the two numerical model responses. The two model responses are identical as expected. This concludes this video on handling wet gas.